All right, so again, direct variation, y equals k times x. Right? K is the degree of variation. K is the degree of variation. Now, notice this is in y equals form. This is in y equals form. Okay, so another thing that we know that is y equals is slope-intercept form. You can go ahead, Blake, that's fine. Is slope-intercept form. So y equals mx plus b is our form that matches this. Okay, the same thing applies, right? This m is the same thing as k. Monica, put it up. All right, now notice that there is nothing after this x. So we could say this is basically plus 0 for my y-intercept. So if I give you the graph and I ask you to identify from the graph if it is direct variation or not, all you're doing is looking if it crosses the origin. If it crosses the origin, that means that you do not have a y-intercept other than 0. Because for it to be direct variation, it cannot have a number after the x. Right? If we look at our formula, y equals kx, you do not see anything right here. So if there's a number after the x, it is not direct variation. On number 13, there is nothing after the x. So this is direct variation. That was the first question. So the first thing says, state if each is direct variation. Yes, it is. If yes, state the constant of variation, which again is k. K, in this case, is 3. So k equals 3. Or m. You could say the same thing, right? Because those match up. The last thing says, find the value of y when x is equal to 12. Well, all you're going to do is take 12, plug that puppy in right there, and solve for y. So I've got y equals 3 times 12. What's 3 times 12? That's 36. Y equals 36. Direct variation. I know it's been a while since we talked about that. Again, that all stems from the formula y equals k times x. Y equals k times x. There cannot be a number after the x for it to be direct variation. There cannot be a number after the x for it to be direct variation. All right, moving on to number 18. Number 18 says, write the equation of the lines using the given information. I give you 2 points. Okay, I give you 2 points. Now, if you look over there on the maroon paper, it says slope formula. Everybody right there on the left side. Everybody look over there on the left side. Look over there on the left side above the board. It says slope formula. M equals, can you read that to me, Monica? What does it say?
M equals y2 minus y1 over x2 minus x1.
Okay, so again, slope formula is the change in y's over the change in x's. Rise over run, which is slope. So y2 minus y1 over x2 minus x1. So what I'm going to do is label one of these 0.1 and one of them 0.2. So in this case, this will be x1, y1. This will be x2, y2. What I'm going to do is I'm going to plug in these values in place of their corresponding letters, right? So y2 in this case is 2. So I've got 2 minus y1, which is 5, over x2, which is 2, minus negative 1. Timmy, what are you doing? Timmy, what are you doing? What are you doing? Why you gotta take your headphones out? Take your headphones out. If you can't hear me talk to you, then take your headphones out. I called your name 5 times.
I heard you the first time.
Why did you look at me?
Because I thought you was like pay attention.
So on the top, I got 2 minus 5. I got negative 3 on the top. On the bottom, I've got 2 minus negative 1. So I can change and make it a positive. I've got positive 3. So a negative 3 divided by a positive 3 gives me a negative 1. So I just found the slope, again, which is m. Slope is denoted as the variable m. It wants me to put it in slope-intercept form. The problem is I don't have the intercept. All I have is the slope and a point. So again, look over there at that green piece of paper. Okay, now that's the one right next to the maroon piece of paper. And it says Pointslope Form. Holly, can you read me what point slope form is? Perfect. So y minus y1 is equal to m times x minus x1. Now, we just found m. So that kitty cat's going right there. Now, it doesn't matter which point you pick. Either one of these, you're going to get the same exact answer. I'm going to pick 2, 2, just because they're both positive. But again, it don't matter. Right? So 2, x1, and other 2, y1. So I'm plugging in my slope, and I'm plugging in a point into point slope form. So I've got y minus the y value of my point. So y minus 2 equals m, which we just found as negative 1, bless you, times x minus the x value, which again the x value is positive 2. So we're there. Now, to convert to this sucker, my first step is to distribute the slope. So I've got a negative 1 multiplied by the x and a negative 1 multiplied by the negative 2. So here we go. Y minus 2 equals negative 1 times x is a negative x. Negative 1 times a negative 2 is a positive 2. So now I'm down to one last step. Okay, my last step is to get y by itself. So I need to solve for y, which means to add 2 to both sides, because I'm going to do the inverse operation. Inverse operation is to add 2, and I get y equals negative x plus 5. There's your answer in slope-intercept form. All right, moving on to number 20. Number 20, I want a line that is perpendicular to this line. So now, the first order of business is to find the slope of this line. Right? So I need to solve for y. I need to put it in slope-intercept form. Okay, so I'm solving this equation for y. Colton, tell me, what is my first step to solve this equation for y?
Trying to get y by itself.
Right, so what's my first step?
It would be to get rid of the x there.
The whole thing, so the 4x, right? And how do I do that?
You would subtract it by itself.
Fantastic. So subtract 4x on both sides. That goes away. You got negative y equals negative 4x plus 7. Now, it's not in slope-intercept form because it's a negative y. I need a positive y. Right? So what I'm going to do is I'm going to divide by a negative 1, basically. Okay, so I'm just going to change every sign that I see. If it's negative, make it positive. If it's positive, make it negative. So that negative y becomes a positive y. That negative 4 becomes, you guessed it, positive 4x. And then the positive 7 becomes negative 7. So there is my equation. Y equals 4x minus 7. Again, what was I doing? I'm trying to find the slope. So, Edie, what's the slope of this equation? Yeah, 4 over 1. So m equals 4 over 1. Now, I want a line that is perpendicular. Okay, it's not parallel. Parallel lines have the same slope. So I know I don't want that number as my new slope. I've got to make 2 changes to that number. So a perpendicular slope has 2 changes. Can anyone tell me what one of those changes is?
The sign.
And we say that's the opposite, right? So to change the sign is to make it the opposite. And then the other word starts with an R. Opposite,
Reciprocal.
Opposite reciprocal. Fantastic. Opposite reciprocal. So opposite means to change the sign. Reciprocal means to flip the fraction. Opposite reciprocal. Monica, you getting this? Opposite means to change the sign. Reciprocal means to flip the fraction. So the old slope was a positive 4 over 1. Now I'm doing the opposite, right? So the opposite of a positive is a negative. So I know my new slope needs to be negative. And I'm going to flip the fraction. He told me it was 4 over 1. I flip it, and it becomes 1 over 4. So I know my new slope of my line is negative 1/4. So now, once again, I have the slope, and I have a point. I'm going to plug it in point-slope form. Okay, which again, Holly told me is y minus y1 is equal to m times x minus x1. Point-slope form. I have a point, and I have the slope. Okay, so Timmy, help me out. I'm going to plug in this for m, and I'm going to plug in these two numbers for x1 and y1. So help me rewrite this equation, but let's substitute in our numbers.
Y is -1.
Y minus what?
Wait, 3.
Yeah, the y value. So y minus
Minus -3.
negative 3 equals m.
Over 1.
M, which is what?
Negative 1 over 4.
Yep, fantastic.
And x equals -1.
So x minus what?
X minus -1.
There you go. Fantastic. So here, okay, this is in point-slope form. Let me clean this up a little bit. This is y plus 3, because I can change on a minus negative, equals negative 1/4 x plus 1. Once again, change. I just cleaned it up a little bit. Same formula. Now, Aiden, how did we get from here, which was point-slope form, to here? What was our first step, Aiden? What did we do? Right, so I said distributed, which means to multiply, so you're exactly right. So we're going to do the same thing down here, Aiden. So this is a negative 1/4 multiplied to that and to that. All right, so help me rewrite this. I've got y plus 3 equals what, Aiden? Negative 1/4 x, great. And then minus, anything times 1, Aiden, is what? Itself, right? Okay, so minus 1/4. Edie, where is it? All right, so now I've got one more step. I want to get y by itself. Okay, I want to get y by itself. Let's see, Monica, what is that last step? I'm solving for y. Yeah, fantastic. So I'm going to subtract 3 on both sides. That goes away. Now I have y equals negative 1/4 x, and I'm just going to say minus 3.25, or you could say 3 1/4. It's the same exact thing. Okay, because I have a minus and I'm subtracting. They're both negative, right? So we can basically add those together. There's my answer. Questions on those 3 problems? What? Okay, let's flip the page over. We're going to go to number 14 on the next page. You get it, Aiden? Got it? Did you get it?
Not yet.
What you been doing while I'm writing?
Just the very last.
Sleeping?
Yes, I have been sleeping for 0.5 seconds.
Well, I mean, I've been done for more than 0.5 seconds. We'll start throwing markers at you. See how well you're sleeping with markers being done, actually. All right, number 14 on the next page. So it says, we're looking at linear transformations now. Linear transformations. It says, if the slope of the line, y equals 1/2 x minus 4, is multiplied by negative 2, and the y-intercept is translated 2 units down, write the equation of the new line and describe the transformation. So my old slope is a 1/2. I'm going to multiply that old slope by a negative 2. Basically negative 2 over 1. and then I'm going to translate down 2 units. So I'm doing 2 transformations to this graph. Now, to review, we've talked about 3 transformations. We've talked about a translation, which is to move the graph up or down, changing the y-intercept. So a translation changes the y-intercept. It moves it up or down. We talked about a change to the slope, the number of the slope, the A. And that was either a vertical stretch or a vertical compression. If the slope got bigger, it's a vertical stretch. If the slope got smaller, it was a vertical compression. And again, I'm talking about the number associated with the slope. I don't care about the sign associated with the slope. The sign associated with the slope, if that changes, that's a reflection across the x-axis. Those are the 3 transformations that we talked about. A vertical translation moves the graph up or down. Vertical stretch or compression, change to the number of the slope. And then a negative to the slope makes it a reflection across the x-axis. All right, so here we go. We're going to take our old slope, which is a 1/2, we're going to multiply it by a -2. So on the top, I've got 1 times -2, I get -2. On the bottom, you got 2 times 1, you get a +2. Blake, what's a -2 divided by a +2? What's a -2 divided by a +2? What's 2 divided by 2, Blake?
2.
No.
Wait.
What's 18 divided by 18? What's 100 divided by 100?
Like I said, I was really bad at math.
Okay, Blake, you got $2. You're going to divide it among 2 people. How much bucks do those 2 people have? Each of them gets how many dollars?
So you said, okay. Sorry.
You got $2. Okay, you're going to divide it between Timmy and Elijah. How much money are you giving Timmy?
1.
Okay, you got $5. You're going to divide it between Timmy, Elijah, Rukin, and Yagiz. How much money does each person get?
1.
So anything divided by itself is?
1.
Okay, so now what's -2 divided by 2?
1.
No.
Wait.
Listen to me. What's a -2 divided by 2? -1. Okay, so my new slope is a -1. So I'm going to write this again in slope-intercept form. So this is y equals mx plus b. I know that -1 is going in place of m because that's the new slope. So that kitty cat's going there. So y equals -x, -1x. You could write -1x if you want. You don't have to write the 1. Now, we're going to go down 2 units. We're going to translate it down 2 units. But we're already at a -4, right? Because this is already -4. So my my y-intercept is already right here. And I'm going to translate it down 2 units. So I'm going down 1, 2 more. Rukin, what is my new y-intercept? -6, -6. There is your equation. And the question asks, what are the transformations that took place? Well, I know that I changed the slope. It went from a 1/2 to a 1. Again, I don't care about that negative. That's a reflection. Okay? It went from a 1/2 to a 1. So did my slope get bigger or did my slope get smaller, Elijah? 1/2 to 1.
Bigger.
Got bigger. So I told you that is a vertical stretch. The slope gets bigger, it's a vertical stretch. All right, Colton, I told you if the sign of the slope changes, what is that?
That would be refraction or reflection.
Across?
The x-axis.
Fantastic. Again, I haven't taught you how to reflect across anything but the x-axis. Okay, so all of my answers should be reflection across the x-axis, because I would not give you something that I have not taught you. There was one more transformation. Timmy, can you tell me what that last transformation was? We changed the sign of the slope, we changed the number of the slope, and we changed what else? I already got it, reflection. You're not paying attention? You're not paying attention? Then you should know. We changed the sign of the slope, we changed the number of the slope, and then what else do we change? There's only one more thing that you can change.
The 6.
Yeah, the 6, which is the y-intercept. Okay, and Rukin said it went from a 4, negative 4, to a negative 6. So what did I do? How did I change? What did I do? I didn't flip it. It went from a negative 4 to a negative 6. You didn't flip nothing?
I mean, you went down.
How many?
2.
Yeah. Translated down 2 units. Don't make it harder than it is. Linear transformations, right? Linear transformations. We know 3 of them. Vertical stretch or compression, change in the number of the slope, reflection across the x-axis, a change in the sign of the slope, and then a translation is a change in the y-intercept. Next thing we're going to look at is going to be number 18. All right, number 18. Number 18, we're looking at scatter plots, lines of best fit, correlation coefficients. All right, so again, a scatter plot is a bunch of points. And between those points, we try to draw what we call a line of best fit, which is what this line is here. And then depending on how close those points are to that line of best fit is my correlation. So if a bunch of those points are very, very close to that line like this is, that is a strong correlation. Number 15 is an example of a weak correlation. Those points are scattered, and they are not as close to that line of best fit as number 18 is. So number 15 would be weak. Right, so we have strong, we have weak, we also have moderate. Okay, moderate is in between. Moderate would be like number 17. They're pretty close, but they're not quite as close as number 18 or 16. Okay, now, Aiden, looking at this graph, that is a strong positive or a strong negative correlation? Fantastic, because those points are going up. Those points are increasing. Strong positive correlation. Number 15 would be a weak positive correlation because it's still going up. Right? Those points are still increasing. 16 and 17 are the exact opposite. Those points are going down. Charlie Brown. Okay, so they're going down. So that would be a negative correlation. This would be a negative correlation. Questions on number 18? Anything on the second page? All right, let's go to number 23. Now, number 23, I taught you how to do this in Desmos. Okay, I taught you how to do this in Desmos. All right, so what you did is you did a linear regression calculator. Let me pause this video because you knew. So again, we had a strong positive correlation because R is equal to 0.9112. It's a positive, strong positive, because it's very, 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 very close to 1. Your strong positives, your strong correlations are close to 1 and negative 1. The cutoff point is 0.5, guys. So 0.5, around 0.5 is a moderate, and then less than 0.5 is a weak correlation. Number 24 says state the linear regression equation. All I did was pull what M was and pulled what B was from Desmos. And then number 25 says generated by 610 theaters, Well, that's telling me to plug in 610 in place of x, because x is my number of theaters. Right? So plug in 610 for x and then find y, which is the gross earnings. Questions on the third page. That is Unit 3. So Unit 3, we talked about finding the slope from 2 points. We talked about writing equations, point-slope form, slope-intercept form, linear transformations, vertical stretch, vertical compression, translation, reflection across the x-axis. And then we talked about scatter plots, correlation coefficients, lines of best fit. And then last but not least, we talked about nothing else. Just kidding. Alright, Unit 4. Okay, this is what we just took our test on. Unit 4. We're looking at number 3 on this page. So Unit 4 involves systems of equations, systems of inequalities, and then word problems on writing my systems. So I'm looking at number 3. Now number 3 says to solve by graphing. On your exam, you'll be able to solve however you would like. So if you want to solve by substitution, bingo, do it. You want to solve by elimination, go for it. You want to solve by Desmos, I can't stop you. Alright, so looking at number 3, I'm just going to graph it on this table right here, on this coordinate plane right here, because it's very, very easy. I'm going to start with my y-intercept, which is a -4. So that's telling me from my origin, let's go down 4 units. So from here we go down 4, there's your first point. The next point we plot is based on our slope. So from that point, I'm going to rise over run. So I'm going to rise 2, run 1. Because it's a positive 2 for my slope, so 2 over 1. So from this point, I'm going up 2 over 1. So up 1, 2 over 1. Bam. There's your second point. Up 2 over 1. Bop. There's your third point. Up 2 over 1. Ding-a-ling. There's your fourth point. So there is your first equation. Second equation has a y-intercept of +3. So from my origin, I'm going up 3. Bop. There's your first point. Now from there, I'm looking at my slope. My slope is a negative. It's telling me to go down 1/3. So I'm going down 1 over to the right 3. So from that point, down 1 over 3. Bop. There's your second point. Down 1 over 3. Bing. There's your third point. Connect them. There's your second line. Now again, a system of linear equations will have a solution as the point of intersection. Let me say that again. Your system of linear equations will have a point of intersection as the solution, unless it's a special case in where there is no solution or infinite many solutions. So what I want to know is, when I say solution, where do those two lines intersect? Well, they intersect right here at 3, 2. Man, that was hard. I want to know the same thing for number 5. We're going to go down and look at number 5. Number 5, I give you 2 functions. I give you a graph and I give you a table. Those are 2 separate functions. And I say, what's the solution? So again, I want to know what is the point of intersection between those 2 functiones. So what I'm asking you guys is, what point is shared by both of these functions? So what point is on this line and also in this table? Because if it's here and it's here, it's got to be your point of intersection. They have to intersect at that point if it's on both functions. So let's look at our answer choices. The first answer choice is 5, 8. Well, if I look at my table, 5, 8's right there. So we're good. Now let's look at our graph. 5, 8 up here. That's not on that line. So A is incorrect. Let's look at D. D is the point 4, 7. There it is right there on the table. Okay, let's go to the graph. 4, 7. Ah, crap. It's not on the line either. So D is incorrect. C, the point 0, 6. 0, 6. Ah, it's on the line. but it's not in the table. 0, 3. So C is incorrect. So we know that B is the correct answer. Now let's look. 2, 5. There it is right there. 2, 5. There it is right there. So again, if it is in both functions, it's got to intersect at that point, because they share that point. So it doesn't matter if I give you the graph, or if I give you a different representation of the graph. This is the same thing as that, except it's just not plotted. So I'm looking for the point of intersection. That is your solution, 2, 5. 2, 5. Questions on the fourth page, 3 or 5. We got dos más. All right, flip your page over. We're on to number 12. We're going to write systems of equations. We're going to write a system of equations. So number 12 says John has 24 coins in his car for tolls on his road trip. The coins are dimes and quarters worth $5.25. How many dimes does he have? So the first thing I got to do is I got to define my variables. In this case, what my variables are, let's say X is the number of dimes. And then let's say Y is the number of quarters. So the first step is always to define your variables. It says John has 24 coins total. So the first equation is going to be equal to 24 coins total. Now, I have no idea how many dimes I have. I have no idea how many quarters I have. But I know that's all that I have. I don't have any pennies. I don't have any nickels. So I've got X number of dimes plus Y number of quarters equals to 24 coins total. So this is coins, dimes, plus coins, quarters equals 24 coins total. So there's your first equation. Now your second equation, it says that they are worth $5.25. So the second equation is equal to $5.25. So I know that I have the total amount of money. So I need money over here. So I need to know how much money I have in dimes, and I need to know how much money I have in quarters. Sam, can you help me write this equation? How do I know how much money I have in dimes? Well, each dime is worth how much, Sam? 10 cents. So I'm going to put 0.1 times what, Sam? Okay. That's how much money I have in dimes, right? Because each dime is worth 10 cents times the number of dimes that I have. Plus, what other coin do I have, Sam? All right, so that's Y. I have Y number of quarters, and each quarter is worth how much, Sam?
25 cents.
So what am I writing right here?
$25.
Yeah, not dot, but 0.25. Fantastic. So there's your system of equations. Now, you can solve that however you want to. Solve it by graphing, solve it by substitution, solve by elimination. It don't matter to me. Okay, what I've done is I've already solved it by graphing. That's not what I want. So let me put my decimals over here. So all I do is plug in the two equations. X plus Y equals 24. Second equation is 0.1, X plus 0.25, Y equals 5.25. Again, this is a system of equation. So I want to know point of intersection. Point of intersection right here. 519. Okay, so write down 519 on your paper. 519 on your paper. The problem is 519 ain't in the answer choices. So are you choosing B or are you choosing C? What's up, Colton?
You choose C.
Why?
Because, dimes are actually the first number.
Absolutely. The question says, how many dimes does he have? We'll go back and look over here. What did I say? I said X is dimes. So I want to know, in my point, what is the X value? 5. Fantastic. Questions on number 12. We got uno más. And then Coach Sapp started talking. So I need a nap, man. I need a nap or a cupcake. I like cupcake. All right, number 16, last one. It says Carlos works at a movie theater selling tickets. The theater has 300 seats, charges $7.50 for adult tickets, $5.50 for children tickets. The theater expects to make at least $2,000 for each showing. All right, so first step again, define your variables. Aiden, help me out. What are my two variables? What two things do we not know, Aiden? We don't know how many of what? Huh? What two things are we selling, Aiden? The theater has 300 seats and charges... Okay, so I'm selling what? I'm selling adult tickets, which would be X, and I'm selling what? Yeah, child tickets, Y. So first step, define your variable, right? So I've got X, which is adult tickets, and I've got Y, which is child tickets. First step is always define your variables. That's done. Next step is to write our equations. So it says the theater has 300 seats total. So right now we know that we cannot let more than 300 people in the theater. Okay, because not only do you not have a seat, but there's also this thing called COVID. And I ain't having more people in there standing around doing nothing. You're either sitting in a seat or you're not there. So I know that my people that I'm letting in cannot exceed 300. So that has to be less than or equal to. I could let all 300 people in there. I could put one person in every seat. So I can be up to or equal to 300. I cannot go over 300. I can only have 100 if I wanted to, but I cannot exceed 300. So I've got X number of adults coming plus Y number of children coming. Less than or equal to 300. The second equation says that they expect to make at least 2,000 buckaroos. So now I'm talking about money, honey. Okay, so I need to know how much money I get from selling adult tickets and how much money I get from selling child tickets. So this is the exact same thing that we did on the last problem. So I know that each adult ticket is $7.50. So Holly, help me write that. How do I write $7.50 and then times the adult tickets that I'm selling? So yeah, 7.5x. Fantastic. Plus, what else are we selling, Holly? Which are how much? So I'm going to write what? So 5.5y. All right, and then the last step, Monica, is to figure out what inequality symbol goes here. What inequality symbol goes here? Equals? Equals is not an inequality symbol, but I agree it could be equal to.
Less than or equal to.
So less than or equal to. Okay, so my question, Rukin, my question is, do you agree with this? 750x plus 550y is less than or equal to 2,000. Do you agree with that? Okay. Elijah, do you agree with that?
I disagree.
What's wrong?
They expect to make 2,000, which means that it could be equal to or more than 2,000.
They expect to make what?
At least.
At least, Monica, you see that? They expect to make at least. So I can go over 2,000, but I've got to make at least. So it's got to be greater than or equal to. This is the amount of money that I get. Money received. Okay, well that's got to be greater than or equal to 2,000. At least 2,000. Now, that's all the question asked me for. All I'm doing is writing the equation, or the inequality, excuse me. But now, if I was to graph this inequality, if I was to graph this system of inequalities, looking at my inequality symbol right here, I know that both of those lines are what type of line, Edie? You have two options. Okay, our two inequalities, when I graph those, they either have a solid line or they have a dashed line. Why are you saying solid? It's equal to, right? There's an equals to bar underneath. There's a line underneath. So the thing that I always say is if there's a line, you draw a solid line. So a line for a line. So if you see an equals to bar underneath, Edie says make it a solid line. Fantastic. The next thing I need to figure out is whether I'm shading above or below. If I'm shading above or below. Alright, so this is a less than symbol, Blake. So a less than symbol tells me to shade above or below? Below. Then this is the exact opposite, Blake. This is a greater than symbol. I'd be shading above. Fantastic. Alright, now, I'm not asking you to do that. I just want to review it. The last thing I want to tell you is, do not forget our one rule of inequalities. Can anybody remind me what our one rule of inequalities is? If I multiply or I divide by a negative number, I got to flip the inequality symbol. Let me say that again. If I multiply or divide by a negative number, I've got to flip the inequality symbol. That is our one rule with negatives.